In the world of engineering, sometimes chaos becomes the teacher. A midnight investigation at an aluminium cold rolling mill revealed a bearing temperature that refused to cool down, even after shutdown, leading to a discovery of triboelectric charging within the oil film itself. On June 25, 2020, just past midnight, a shift operator noticed something odd at the aluminium cold rolling mill. The bearing temperature of a 1000 kilowatts DC motor suddenly spiked to 70 degrees Celsius, even though the motor was no longer running. This observation opened a doorway into understanding a failure mechanism that defied conventional wisdom. When all usual explanations fail, the investigation begins. The team replaced the bearing, attempted a restart, but the bearing started smoking again. It was a pattern that looked like chaos, challenging the norms of typical mechanical failures. The chaotic pattern emerged as vibration waveforms were non-periodic and self-amplifying, a dance of disorder driven by multiple interacting energies. This led to the discovery of triboelectric charging inside the oil film itself, a phenomenon engineers seldom consider. The unseen enemy was when oil turned into a capacitor. The Slinger ring effect, charge accumulation, and plasma discharge were all contributing factors, creating electrostatic charge in the bearing oil housing system. The catastrophic results were evident as the bearing temperature kept rising even after shutdown due to residual plasma activity. Fresh oil degraded within hours, and the bearing inner race showed physical damage, revealing a triboelectrochemical event. The failure sequence was revealed through friction initiation, charge accumulation, discharge events, plasma formation, oil breakdown, and EDM damage. Each step contributed to a cascading failure mode. Three invisible layers, mechanical, thermal, and electrical, overlapped in a catastrophic collaboration. Misalignment, high local heat, and triboelectric discharge led to catastrophic etching, showing how failure is a collaboration between imperfections. Lessons for every plant engineer include monitoring oil health beyond viscosity, revisiting viscosity grades, replacing oil seals proactively, maintaining proper fits, and respecting storage orientation. Each lesson contributes to systemic elegance and reliability. Chaos is data, and the broader lesson is to interpret failure rather than suppress it. 5 years have passed, and the bearing did not fail again, showing that understanding failure is key to preventing it.